Hello, I'm Spiros Miselis. I will be presenting full rates of exercise throughout the year for IB exams, and I hope it helps your case. Hello again. In the previous lesson, we learned that for the stoichiometric calculation, we need an amount of reactant that reacts completely. Let's see case 2. Calculation when the amount of two reactants are given. We call excess control. Even the synthesis of nitrogen dioxide, we have the balanced equation and the reacting ratio by mole. 1 mole nitrogen reacts with 2 moles oxygen and gives 2 mole nitrogen dioxide. We distinguish the cases. Case 1. Reactants in stoichiometric ratio. Whatever we have, bemol nitrogen and 2b mol oxygen. In this case, the reactants react completely with each other. Finished products are 2b mol nitrogen dioxide. Let's see case 2. Nitrogen in excess or oxygen in limiting. Whatever we have, C-mol bigger than B-mol nitrogen and 2B mol oxygen. In this case, oxygen reacts completely with part of the amount of nitrogen, of course in the mole ratio according to the stoichiometric coefficients. So, the finished products are C min B mol nitrogen and 2B mol nitrogen dioxide. Third case. Oxygen in excess or nitrogen in limiting. Whatever we have, bmol nitrogen and dmol bigger for 2b mol oxygen. In this case, nitrogen reacts completely bmol with part of the amount of oxygen, of course in molar ratio according to the stoichiometric coefficients, 2b mol oxygen reacts. So, the finished products are D mean 2b mol oxygen and 2b mol nitrogen dioxide. So in these cases, we must find if we have reactants in stoichiometric radio or excess from one of the reactants. Let's see some examples. How we succeed the excess control. Example 1. Nitrogen dioxide can be prepared from the reaction nitrogen and oxygen give nitrogen dioxide. If 112.08 grams nitrogen are reacted with 320 grams oxygen, determine the mass of nitrogen dioxide that can be formed. Let's see the solution. This is a very important problem in chemistry calculation. First, we write the balance equation and the mole ratio of interest. Nitrogen and oxygen gives nitrogen dioxide. The mole ratio is 1 mole nitrogen, 2 mole oxygen, 2 mole nitrogen dioxide. Then we calculate the mole of each reactant. First, for nitrogen, we have calculate the mole of nitrogen. We know grams, so we have to convert grams in mole. So we need MR. and we find the number of mole. We divide the mass of nitrogen with molar mass of nitrogen. And we have 4 mole nitrogen. Then we calculate the mole of oxygen. We need the MR, and we find the mole. And the number of mole is 10 mole. Of course, we don't know which reactant reacts exactly, so we have the excess control. Let's see how we succeed excess control. Let's see the first way for excess control. We suppose that reacts completely the amount of nitrogen. So we have 1 mole nitrogen reacts completely with 2 mole oxygen. So the 4 mole of nitrogen needs bemol oxygen. We solve the ratio and we find the number of mole of oxygen. So we find that the 4 mole of nitrogen needs 8 mole of oxygen. We have 10 mole of oxygen available so this is in excess and nitrogen is the limiting reactant. Is the same to suppose that reacts completely the amount of oxygen. We have the same result. So we suppose that reacts completely 10 mole of oxygen we have. Two mole oxygen we solve the ratio we have 4 mole of nitrogen available, so the oxygen is in excess and nitrogen is the limiting reactant. One of the two ways we can find if a product is in excess or in limiting. Let's see the second way for excess control. We find mole ratio from equation. The number of mole of nitrogen, the number of mole of oxygen is equal 1 divided by 2, and we find 0.5. Then we find mole ratio from given mole. Mole nitrogen, mole oxygen equal 4 divided by 10 equal 0.4. As the ratio of the given mole is smaller than the required ratio in the equation, it means oxygen is in excess and nitrogen is the limiting reactant. So we find that oxygen is in excess, so the stoichiometric calculation based on the amount of the reactant that is limiting. So we have the stoichiometric calculation. Based in the amount of nitrogen. 1 mole nitrogen gives 2 mole nitrogen dioxide. 4 mole nitrogen gives the mole nitrogen dioxide. And we have to solve the ratio to determine the mole of nitrogen dioxide. So we find out that we product 8 mole of nitrogen dioxide. But we need the mass of nitrogen dioxide, so we have convert the moles, the 8 moles in grammars. So we need mR of nitrogen dioxide. We use the formula to convert the number of mole in grammar, so we have so the answer is that produced 368.08 grams of nitrogen dioxide. Example 2. Synthesis of ammonia is given by the reaction. 84.06 grams nitrogen are reacted with 227 dm to the cube hydrogen at STP. Calculate the mole of each substance that will end up in the container. First, we have to write the reaction between nitrogen and hydrogen to give ammonia. And we write the ratio mole of interest. 1 mole nitrogen, 3 mole hydrogen, 2 mole ammonia. Given the amount of the two reactants, so we have excess control. So we calculate the mole of each reactant. First, the mole of nitrogen. We need mR to convert grams in mole. And we use the relationship to find the numbers of mole. The numbers of grammar are divided by molar mass of nitrogen. And we find 3 mole nitrogen. Then calculate the mole of hydrogen. We use the formula to convert the volume of the gas at STP in mole. So we have and we divide with molar volume at STP. And we find 10 mole hydrogen. Then we have the excess control. We suppose that react completely the 3 mole of nitrogen, and we have 1 mole nitrogen reacts with 3 mole hydrogen. If reacts 3 mole nitrogen, bemol hydrogen also react. So we have to solve the ratio and to find the bemol of hydrogen. We find 9 mole of hydrogen are reacted. We have 10 mole hydrogen available, so this is in excess. Then we have the stoichiometric calculation using the 3 mole of nitrogen within limiting. 1 mole nitrogen gives 2 mole ammonia. Reacts 3 mole nitrogen and we have 7 mole ammonia, and we solve the ratio. So we have 6 mole ammonia. Final, we will have 6 mole ammonia which are produced and 1 mole hydrogen. This is the answer. Let's see case 3. Calculation and percentage yield. We have the definition. Percentage yield is equal experimental mole of a product divided by theoretical mole of the same product times 100, or A is equal mole experimental of product X, mole theoretical product X times 100. Let's see an example. $488.52 benzoic acid dissolve in an amount of sodium carbonate solution containing 2 mole of solute, and the reaction is carried out benzoic acid reacts with sodium carbonate to give benzoic salt and carbon dioxide and water. In experiment, they are released 36.32 dimet to the cube carbon dioxide at STP. Calculate the percentage yield of the reaction. Let's see the solution. First, we write the balanced chemical equation. And the mole ratio. Two mole benzoic acid, 1 mole sodium carbonate, and 1 mole carbon dioxide. We calculate the mole of each reactant, and we have excess control because we have 2 reactants moles to given without to know which reactor completely. First, the mole of benzoic acid. We find first MR, but we have to analyze the benzene ring to calculate MR. So we have MR is equal AR of carbon times 7 the number of carbon atoms AR of oxygen times 2 and AR hydrogen times 6. The result is 122.13. We use formula to calculate the number of mole. So we have the number of grammars divided by molar mass. And we find 4 mole benzoic acid. For sodium carbonate, we have the given mole, 2 moles, and then we have excess control. Let's see it. 2 mole benzoic acid reacts with 1 mole sodium carbonate. We suppose that reacts completely the amount of benzoic acid, 4 mole, to give bemol sodium carbonate. We solve the ratio, and we have 2 mole sodium carbonate. We have 2 mole sodium carbonate available, so they react completely. With each other. So we have stoichiometric calculation. 2 mole benzoic acid gives 1 mole carbon dioxide. The 4 mole of benzoic acid gives a mole carbon dioxide. We solve the ratio. And we find 2 mole carbon dioxide, which the theoretical amount. We know that for carbon dioxide, the experimental mole is equal with the volume of experimental 36.32 dm to the cube divided by the molar volume. So the number of experimental mole is equal 1.66 mole. So we know the experimental mole and theoretical mole, so we can find the percentage weight. So we have 1.6 divided by 2 times 100. So the percentage yield is equal to 80. So we have 80% yield. Let's see case 4. Calculation in more chemical reactions. In these cases, we have calculations in a mixture of compounds or elements or in consecutive reactions. Let's see two examples. First example. We have an example in the case of mixture. So we have a solution contains 4 grams sodium hydroxide and 14.82 grams of calcium hydroxide. Calculate the mole of hydrogen chloride required to completely neutralize the two bases. Let's see the solution. First, we write the two chemical reactions. First, for sodium hydroxide, and second, for calcium hydroxide. we balance the two equations. It's okay the first and the second we have the coefficients, and in each reaction we write the ratio of mole. 1 mole hydrogen chloride with 1 mole sodium hydroxide in the first. In the second, 2 mole hydrogen chloride with 1 mole calcium hydroxide. Then we calculate the mole of sodium hydroxide and calcium hydroxide, the two substances of the mixture. For sodium hydroxide, we have first MR, is equal with 40, and we convert the grammars in mole. And we find 0.1 mole for sodium hydroxide. The same with calcium hydroxide, is equal 74.1, and we find with the same way the number of mole. So we have 0.2 mole calcium hydroxide. And then we have the stoichiometric calculations for each chemical reaction. We have in the first 1 mole hydrogen chloride reacts with 1 mole sodium hydroxide. We have 0.10 mole sodium hydroxide, so we need bemol hydrogen chloride. We'll solve the ratio, and we have the number of mole of hydrogen chloride which reacts with the amount of sodium hydroxide. In the second reaction, 2 mole hydrogen chloride reacts with 1 mole calcium hydroxide. When reacts 0.20 mole calcium hydroxide, we need some mole hydrogen chloride. We solve the ratio, and we have so the number of mole is 0.40 mole. So we have the answer. Required 0.10 plus 0.40 is equal 0.50 mole of hydrogen chloride. This is an exercise which have two reactions and we have a mixer. Second case, in consecutive reactions. In these cases, the product of the first reaction is reactant to the second reaction, etc. The stoichiometric calculation of a reaction is based on the amount of the reaction before. Let's see an example. In the past, for the preparation of acetylene, we used limestone using the following reactions. Calcium carbonate gives calcium oxide and carbon dioxide. The product of the first, calcium oxide, reacts with carbon and gives charcoal and carbon monoxide. The product of the second, charcoal, reacts with water and gives calcium hydroxide and acetylene. Calculate the mass of acetylene that will be prepared if we use 4.0036 kilogram of limestone. Consider all reactions, quantitative Let's see the solution. First, we write the reactions. The first one, and we want to calculate the common compound is calcium oxide. So we have the mole ratio. 1 mole gives 1 mole, and you calculate the calcium oxide from calcium carbonate. So we need mole of calcium carbonate. We find the MAR. And then we convert the kilograms in mole. So we have 40 mole of calcium carbonate. We have the stoichiometric calculation. 1 mole of calcium carbonate gives 1 mole of calcium oxide. 40 moles gives bemol calcium oxide. We'll solve the ratio. And we'll find 40 mole calcium oxide. The next stoichiometric calculation is based in the amount of calcium oxide with the common compound. The second equation. We have the second equation, which is given, and we write the ratio, the mole ratio. 1 mole, 1 mole. 40 mole of calcium oxide gives mole charcoal. So we have to solve the ratio and to find the next common compound. So we have 40 mole of charcoal. We write the final equation, and stoichiometric calculation is based in the amount of charcoal. And so we find the amount of acetylene. We write mole ratio. 1 mole gives 1 mole. 40 moles gives the mole. So we have to solve the ratio. And we find 40 mole of acetylene. So we have the answer. 40 mole of acetylene are prepared. Thank you for listening. I hope to help you. We see a next lesson in a few days. Thanks for listening and more IB chemistry videos to come. If you like the video and you can support me on Patreon. Thank you.